to introduce you to Geometry, Chapter 10, Section 6, which deals with secants and tangents and how they intersect circles and the angles formed by those intersections. I want to show you this picture. It's a picture of a place that you may know. It's called Stonehenge. It's located in southern England. We don't quite know what it was used for, but one guess is that it might have been possibly used as some form of clock, some sort of measure of time or a calendar for this ancient civilization that constructed it. You can see that if you were to stand at an observation tower and you were to peer through, your line of sight is going to pass through all sorts of different objects that are in the circular shaped Stonehenge. So depending on where you are, depending on the time of year, where the earth is in position to the sun and where the moon is in position to the earth, you're going to get all sorts of different angles. So these angles can be formed by a secant, which is a line that passes through a circle at 2 points, and a tangent, which is a line that passes through the circle at 1 point. So for you to stand on this station stone, you're going to have a tangent line intersecting at point M into secant CA. And for example, if that angle of intersection were 23.5 degrees, and the first arc of intersection, this minor arc right here, AB, where this angle BMC is intersecting, if that minor arc is 71, we want to find out what this other minor arc BC is going to be. And in order to do that, I want to take a look at this interactive diagram that I've made. You can see that as I change the points in here, it'll change the measurements on the diagram. So those arcs, the two minor arcs down there, those will change as the angle is changing. So I want to find out what that relationship is. Well, if I were to add the two minor arcs together, they would be far larger than the angle of intersection that they form. If I were to divide the two, again, that would be far too small to get this angle of intersection. So instead, what I'm going to do is I'm going to subtract the smaller arc from the larger arc. And I get 70.066. Well, that's actually exactly double the rounding of this angle of intersection. So if I divide their difference by 2, I would get exactly that angle of intersection. So let me move this around again so you can see no matter how these move, this angle of intersection and this calculation right here stay exactly the same no matter how this moves. So that gives us a formula right here. So if you want to pause your screen and record this formula, minor arc DE subtracting minor arc BC. So if you subtract those two and you take half of that difference, it'll get you the intersecting arc on the outside. And that applies to tangents and secants, or secants and secants. So for example, if we go back to Stonehenge, if we want to find minor arc BC, we could set up this equation. We would take minor arc BC and subtract minor arc AB, so BC minus AB, and we divide that difference by 2. That's going to get us our angle of intersection, angle AMB. That angle is going to turn out to be 23.5 degrees, which is given to us. So if we plug those in, we solve for those numbers, we get 118 for minor arc BC.